I picked up a load of stepper motors on eBay. It's a big box of just random stepper motors that somebody had harvested out of old printers, and in it contained quite a number of these little OKI stepper motors. So these ones here, I believe they're from printers, and wasn't quite sure what I was going to do with the box of stepper motors when I ordered it, but I decided to have a little go at making a drawing robot. There's loads of them about using NEMA stepper motors, but classic case of work with what you've got, so I thought I'd have a look and see if I could make these work. The box with stepper motors contained all sorts of various bits and pieces, but I thought first of all I'd try using just the bare stepper motor without the gears. Now it's quite fortunate, I don't know if it's intended to be this way or not, but the motor pinion, this little pinion here on this particular stepper motor, and this one as well, which I showed you, the tooth pitch of this gear is the same as the pitch of a GT2 belt. So you just wrap a GT2 belt around them and away you go. The only downside to that, which I quickly discovered and then switched out to using them with the gears still attached, is that these stepper motors are 7.5 degrees per step. So you can see here it says 7.5 degrees per step. Now a standard stepper motor, the sort of NEMA type that you get in a 3D printer or something similar to that, are 1.8 degrees per step, which means every time you feed it a step, a standard NEMA just moves just a tiny little bit. With micro stepping you can get very good resolution just using the micro stepping on the 1.8 degree per stepper motors, but these ones at 7.5 degrees per step just go clonk clonk clonk, and the movement on each step is far too big. Also micro skid stepping doesn't seem to work particularly well with these, and I think probably because there's such a big rotational movement per step, the sort of phasing or the manipulation of the coils can't really make it find midpoints particularly well. It certainly smooths the motion out, but you certainly can't use 16 times micro stepping to get down to a fine resolution. So I then use these. Now what's also fortunate about these is that this little part here of the pulley, that's also the same pitch as a GT2 belt. So on my drawing robot I would just kept the gear reduction here, which I think, I haven't counted it, it's probably something like 20 to 1 or something like that. It means that our 7.5 degrees per step suddenly becomes much more controllable and gives a nice fine resolution on this geared output. And the GT2 belt just wraps around this little sprocket here and works perfectly. The frame of the robot just consists of some 3D printed parts. So we've got a 3D printed end plate there with the 8mm rods pass into. It's got an idle pulley, and then an identical one at the bottom down here, and then the stepper motor is just screwed to a piece of plywood with the belt wrapped around it. And then the carriage sections in the middle are just a very simple sort of U shape with a pair of holes here that take standard LMU or LM8UU linear bearings. There's 2 linear bearings in each of these, and then this one behind is exactly the same. There's just 2 separate parts that are printed out, flipped 90 degrees and then screwed and glued together. So that gives us our X and Y carriage for the linear bearings to run. At this end there's a little holder here that takes another one of those stepper motors, just quickly knocked up in Fusion and 3D printed. The Z end of this uses one of the little carriage motors from an optical drive, CD-ROM drive. Works in exactly the same way. It's a bipolar stepper motor, and that's just got a little carriage there with some linear bearings, a little hole at the front there to take a pen. in order to send G-code to it, I'm just using universal G-code sender, just the nightly build, the standard one. You can download that for free off the internet. I will do another video which covers the software side of this. To generate the G-code, I'm just using Inkscape with its standard G-code plugins and also raster to laser G-code. I'll do a little follow-up video which goes over the software side of things. There's lots of videos on YouTube that show drawing robots, drawing things, and how to make them using old CD-ROM drives and things like that. So it's easy enough to mechanically create one using some step motors, some GT2 belts, some linear bearings, and that wasn't difficult. It did take a little bit of time understanding and setting up the G-code plugins for Inkscape, understanding how they actually work, installing universal G-code sender. We've got two different ways that we can draw with it as well, using vector and raster. And there's lots and lots of videos, as I say, showing drawing robots drawing, but not many of them actually cover the software side of it. So